All right, so at this point in the semester, it's got to feel like you've been doing equilibrium forever. Here we are. We have a question about molar solubility for magnesium hydroxide. It wants to know the solubility product, and the solubility product is the equilibrium constant for the reaction where we take a solid and we dissolve it in water, but we remember that it's an equilibrium. It doesn't fully dissolve all the way. It only dissolves to a certain degree. And that equilibrium is represented by this equilibrium constant. We call that the solubility product. Now, you approach it in the same way you do every other equilibrium, and that's to say that I'm giving you the equilibrium constant, and we can use an ice table in order to sort this business out. Now, the thing is that since magnesium hydroxide is a solid, it doesn't get included in the equilibrium expression. And so that part of it isn't there. And that does lead to some confusion. And we'll address that a little bit later on. The rest is very straightforward, though. I start out with 0. This goes up by x. This goes up by 2x. X is the equilibrium concentration of magnesium ion, and 2x is the equilibrium concentration of hydroxide ion. And so the equilibrium constant KSP equals the concentration of magnesium times the concentration of hydroxide to the second power. And that's not that should be actually the concentration of hydroxide, not 2. So let me fix that. Now, that means that 2.06 times 10 to the negative 13 equals x times 2x quantity squared, because that's the concentration there. And so 2.06 times 10 to the negative 13 equals 4x cubed. Now, this is the first time you've seen something like this, but this is a third degree polynomial. And so we don't have a formula for, you shouldn't have learned a formula for third degree polynomials like you did second degree polynomials, in other words, quadratic equations. So how do you solve this? Well, in this case, this one's very straightforward. We're going to divide by 4, so I get x cubed equals 5.15 times 10 to the negative 14th. And so if I take the cube root of both sides, I get x equals 3.72 times 10 to the negative 5th. Okay, the question is asking me about the molar solubility. What is the molar solubility of magnesium hydroxide? Well, what is the molar solubility? This is where having magnesium hydroxide being a solid is a little bit confusing. So let's start off with this particular problem and do an explanation. And let's just pretend for a moment that we would include magnesium hydroxide. Let's say that it starts off at 1 molar. So initial concentration of 1 molar. Well, we would say it goes down by x, that some of the magnesium will dissolve, we'll call it x, and then that's what everything else is. Then magnesium ion goes up by x and hydroxide up by 2x. And so under equilibrium concentration, we'd have 1 minus x. So what is the molar solubility then? The molar solubility is how much of the substance will dissolve based, in molarity. And so it turns out that the molar solubility, it's just x. It's just the x in the ice table. That's what the molar solubility is. Now, this stuff isn't included in the ice table. It's a solid, and that's why we need to remember that x the magnesium hydroxide is one thing. It is reduced by a particular amount, and that amount is x, but that amount x isn't included in the solubility product because magnesium hydroxide is a solid. So when we think about the molar solubility, we want to remember that whatever we're doing with the ice table, the molar solubility is x. And so it turns out that we've already sorted out what the molar solubility is. It's 3.72 times 10 to the negative 5th molar. Okay.